here are filled with plastic. They melt under a powerful field, then they cool, and then I'm hoping they will hold a charge. And so that's kind of the basic overarching purpose of my experiment. So this is my shop. I just started putting together, so I'm pretty excited. And I have all these different plastics and sprays, and those are my DeWalt tools. I've got all kinds of cool stuff to work with. Candle waxes, palm tree wax. There's Rochelle salt that's used in food. And so just a whole bunch of cool stuff. And then below, I have those molds I was telling you about. So I just bought these are candy molds. Those are for making chocolates. Here are cupcakes, different kind of molds. And here I have sort of my specialty powders. That's mica powder. There's the road glass, mica, I'm sorry, another type of plastic. And that's pretty much it. But this is just me getting started. And then here's the other side of the garage. So now that my 4 adult kids have moved out, I get to take their space in the garage. So this is sort of my setup here. And there's my baby right there, my truck. All right, so I'm just gonna focus right now just on materials, and then we'll get into how to make electrets, and then later we'll go on how to test them. Now I'm using 2-part epoxies as a binder for some of my experiments. So here I'm mixing in a little Teflon, and I'm mixing it in with a little A epoxy part of the epoxy resin. Here there's negative, and so if I'm going to make an electric using this as a binder, excuse me, putting them in those little squirt bottles makes it very convenient. I use these copper sheets, and you can see that I sand them every time I use them because they get covered with an oxide when I heat them up. This little sander here is probably the best tool I bought from China. This thing costs 15 bucks. It's a goofy little DC motor, but I use it to score and sort of take the rough oxidation off the copper wire, because I need the copper wire to be exposed to provide the more consistent electric field. So this is kind of the materials and tools that I'm using for the copper plates. So I don't know if I do it here. Here I'm mixing this stuff together. Oh, I see. So I'm going to tape these to this bar here. And then if you guys remember me when I was using the rotisserie for building my coils, here I'm using in the rotisserie to mix the powder with the epoxy. And it worked really well. I let it run for an hour, and the consistency was really, really, really good. Just another video of it. I bought these little hygrometers. They're totally cool. They're very cheap. You get them for 20 bucks for 4. And I use them for the temperature and the humidity. Humidity needs to be under 50%. Otherwise, there's a microscopic film of water that coats everything. And that microscopic coat of water that coats everything, that's going to short out all of your little charges you're trying to build. So humidity is the enemy. Now, on the flip side, if you're working with electrostatic sensitive materials, then 50% or higher humidity is your friend, because you're not going to get that static charge. So what I do is I use the heat of this barbecue pancake grill, or whatever you call it, I picked up from the thrift store, and I heat it, and it creates its own zone of low humidity. So as long as I stay within that zone of low humidity, I'm allowed to work on my electrets, which is with the hope of charging them with electricity. So here I'm experimenting with sound, and I wish you could hear the sound, but what I'm doing is finding the resonant frequency of the workbench, this grill, and the items on the grill. Now you might be wondering, how am I doing that? Well, what I'm doing is this little subwoofer here. I'm running frequencies through it, and it's on this aluminum heatsink, and the vibrations transfer from the heatsink to this grill, and then the grill vibrates, transferring it to the workbench. So when I dial it in perfectly, everything shakes. Now this is a super thick, super heavy workbench, and yet it vibrates as if it was made out of balsa wood. I mean, it's incredible. And so I'll just tune it to everything. Sort of has this vibration, and then there's this sort of hum. It's almost like oh boy, it's not a hum. It's a yeah, I can't explain the sound, but that's when you hit that. That's when you know you've hit the resonant frequency. And this desk here is connected to another workbench to the left, and they're separated by about 1 millimeter. And yet, when I hit the resonant frequency of the bench on the right, this bench, everything is vibrating, but the other bench is perfectly still. So you can tell then you sort of isolated this undamped movement that's being transferred to everything. Now, my hope is eventually is I'm going to try to find the resonant frequency of the actual plastics that I'm putting inside these molds. And then that way I could really undamp, mechanically resonate the materials so they're I guess overdamped and more receptive to being controlled, controlling their polarities. I think this is just another test that I'm doing, and I thought that it's neat to see visually. Right now, it's changing different frequencies, but you can tell me when as it hits resonant frequency, you can actually visually see it, which is fascinating. You see, I'm getting close. I've done this with different materials too, and they're different frequencies. If I put glass up here, it does the same. And in fact, if I get really close, it'll actually jump right out. I'm not sure if it does it in this one. But here I'm just trying to play with frequencies to see if I can really get into the frequencies that are inside, the resonant frequency inside. This is a lubricant that I use. Here you can see I made a little brew. I put it in the silicone molds. These are made for small cupcakes. And I filled it in, and now I'm going to put the copper plate on top. It'll be sandwiched in between a field of tens of thousands of volts. And I'll add a little bit of vibration here, like I shared earlier. So now we're getting heat, we're getting an electric field, and now we're getting sound, or basically vibrations. And again, what I'm trying to do is, I guess, disrupt these molecules so they align, and they align within the polarities of the high voltage power supply. This is the plastic I highly recommend anybody and everybody that needs a tool or needs an instrument, and you don't have a 3D printer handy. This plastic is incredible. It's called, its technical name is PCL. If you look up PCL plastic, what it does is it has a melting temperature of 140 degrees. And so this hot water causes it to melt, and then you put it in your hands. You can make anything you need, like a quick, I made a quick stand for my meter right when I needed it. And then when I was done with it using in that capacity, I throw it in a cup of hot water and I make something else out of it. When it dries, when it cools, it's very hard. It's a really decently hard plastic that you can make into anything. It's funny because it's just a kid's thing, but I use it now on a number of things. Here I made this real complex design here. It's called the hand and the palm design. No, seriously. I was rubbing different plastics on this to see that if this was positively or negatively charged, because I wanted to use this special plastic in my Electrets. So that's why I have this little goofy design here, because I just kind of wanted to stretch it out so I can cut some chunks out of it and have it do different things. Here's another thing that I'll do. I'll coat powders on these pellets. And so this is another way. And here are the ziggurat molds that you'll see from the ziggurats that you saw on the first slide. These are made for candy. And so you got to they're they're not really, oh, you can get these at Amazon. I think I ordered this from a bakery site. And so these unique shapes are pretty fascinating. And I found out that this geometry has some boy, what's the word? Some properties that were I couldn't have guessed what they would be, and they're still a little bit mysterious. A nice thing to do is pre-charge. This comes from directly from Brent Jarvis's patent application. He talks about this, how you can pre-charge materials. So before I put my materials in the mold, I'll put in a powder and to interact with the plastic pellets, and then I'll just shake it in the bag. And when I pour it out of the bag into the mold, some of these are so charged, they're like Mexican jumping beans, and they'll just jump right out of the mold. So that's what pre-charging is. Here you can see I have all kinds of different plastics I'm experimenting with. Another big thing I do is this toaster oven I too got from the thrift store. Actually, I think it was given to me. This preheats the plastics. That way, when I put them on the pancake grill, it's not just a one-sided heat, but it actually has a more thorough heat, and therefore more of a charge can be placed in them. So this type of plastic here, if you try to buy, let's say, 2 pounds of it, they'll charge you about 12 bucks, 15 bucks a pound. And here I got 25 pounds for about 15 bucks. And the reason for that is you have to sort of get off the beaten path. You know, I'm looking at candy store molds. I'm looking at, these are for filling children's toys or blankets. And so I'll talk a little bit more about that later, but I'm kind of showing off how this is very expensive unless you really look for it at places that use it differently. This is another, it's called the smokeless grill. This is my upgrade from the thrift store, then my pancake grill. And as you see here, I'm creating an environment that's under 50% humidity because that's important. It's 82 degrees in my garage, which is quite warm, but yet heating up this grill, this whole area becomes friendly to building up strong static charges. And I'm really liking this grill. And so I'll use this grill to adjust to different temperatures. And what you'll see here is, okay, this is a certain humidity, this is a certain temperature. That's what I'm going to work with. So sometimes I work inside the grill, sometimes I work on top of the grill a little bit, and this gives me the variability that I need. Another thing is they have this stuff where you spray, and what it does is it protects your, let's say, clothing from getting soaked in the rain. And so if you, I think it's called hydrophobic spray. And so if you use that spray, you can spray it on your shoes, you can spray it on your t-shirt, and then go out in the rain and everything will be waterproof. Well, the stuff is kind of expensive. And so I had this this can of pause here, of just clear gloss. It was like $4 at Walmart, and so way cheaper than the hydrophobic sprays. And yet, when I sprayed it onto this ziggurat, it came out perfectly. It sealed it. So this became resistant to the humidity. When the humidity is 50% or higher, my electrets charge are cut in half because it's fighting the microscopic film of water that's covering everything and shorting everything out. So spraying with this cheap spray now seals it. It's pretty cool. Worked out. Now this is one of my one of my attempts to grind the plastics into powder, because if you want to find this powder, this plastic in a powder form, it's hundreds of dollars for like a few ounces. I don't know why that is. It seems absurd. Why is it so hard to take this pellet and send me it in powder form? So I bought this this grain mill, And my hope is I'm going to figure out how to get these blades adjusted and then grind this plastic into powder. That way I can get more of a consistent plastic. So that's my reasoning there. And the nice thing about buying the grain mill is my wife and I have a little homestead up north in Wisconsin. And so it's always nice to have something that's going to be able to grind the grain that I'm going to grow on the property, or corn or whatever we're working with. So it's kind of nice that these pieces of equipment have dual purposes. My wife doesn't buy that excuse. She says that I'm just buying it because I want it, and she's sort of right. So this is going to be my next power supply. This mean looking Marks generator is going to provide minimally 1.5 million volts DC. So right now I'm working up to, with my current, I'm working up to 100,000 volts DC. And actually I'm only getting maybe a fraction of that because of other technical difficulties. But this thing is going to give 1 million volts, and it's going to give it in a sort of a nasty way. It's going to just send a positive pulse, just jerking the plastic that I'm going to put in between. It's going to just be jerking those atoms into place. And so I have to build a safety area. I have to build safety around it, fire extinguisher. I'm even going to put a little bit of, I think I'm going to cover it with a blast shield that I made. But this is what's going to be supercharging my Electrets down the road. Let's see. Here I'm trying plastic discs, and I'm putting them, again, I'm cutting out the molds here. I'm going to put a plastic disc here, heat it up, run some electricity through it, see if I can charge the discs. I've had no luck with it yet, so nothing exciting. I just took this piece of copper outside because I sanded it and then I put it in the heat, and it turned all these colors. And these, because it's pure copper and it's oxidizing at a certain rate, I just thought, wow, it's just almost a piece of beauty. Here's what it looks like inside versus that was out in the sun. But again, it has these amazing colors. I think I just finished sanding that side. And I'm always cleaning these things up because every Electret experiment, these things get covered with oxide, and then I gotta clean them up. And it's a labor of love. It's fun. Here you'll see that if you saw earlier, I filled in those molds. Here you can see that the copper plates at the bottom, these molds have finally solidified. And so I'm just going to take these things off now and test them. And we'll see some testing later. Because if you remember, I have three sort of topics in this video. The first are equipment and materials. Second is how I make them. Third is how I test them. So this is just a light bulb. I'm just picked it up playing around because I wanted to show you the plates look like they're doing nothing. But if I connect the wire, you can see that the plates have a powerful electric field between them because it's right now going through this light bulb and it's going through here. Now this is only about 5,000 volts, but it's the only really visual way I can see that there is an actual electrostatic field between my plates by just touching one wire to one end and one to the other. So the Electrets are inside here brewing. You'll also see that I'm using ground. Sometimes I'll have the ground on the negative side. Sometimes I'll have the ground on the positive side. And I'll share a bit more about that later. The goal is always to try to find non-conductive molds in order to place materials that I can charge. And so PVC pipe, PVC has a higher melting temperature than my other plastics. So I can use rings of it, fill it up with the other plastics, and then put an electric field on top and bottom and melt the plastic inside. And so these make great molds, not the greatest. I'm actually starting to play with clay because clay will be the ultimate, but the goal is always to have the plates of the copper touch each side of the Electret while putting as much electricity through it as you can. And so that's the challenge here, and that's the purpose why I'm cutting these rings. And this is an amazing tool. I don't know if you've ever seen this. Vevor, and I get no kickback from Vevor, but VEVOR, every single one of their tools are incredible, and they're a fraction of the price anywhere. You'll never find a cheaper set of tools. My grain mill was a Vevor. This tool's a Vevor. My vacuum chambers a Vevor. I mean, I can go down the list of all the Vevor tools I have, and you'll see them in videos. But if you're looking for something cool like this, excuse me, you can go to Vevor. Excuse me, sorry, one second. Sorry about that. So yeah, I highly recommend them. Their motto is half price tools, and it is. Their stuff is way cool. So this is what the plastic looks like when I'm putting it in the toaster oven. And I think I'm going to bake these. I bake them until they're clear. There are 3 phases when you're working with polymers, another word for plastics. First phase here is this solid phase. The second one is where they turn clear. And I think that's called the glass or glassy phase. And then there's the melting point. And the melting point then when it becomes basically as much liquid as it can based upon a number of factors. But working with it in the glassy phase is what I want to do. So here I'm setting the toaster oven. These are the settings that achieve that. And here you can see now under temperature, here we go. So this is the glass phase. You can see they become this crystal clear. And this heated up to about 380 degrees. It's just under, I'd say just under 400 or no higher than 400. This was a trick, not a trick, but a technique I call it the brownie approach. So you know how you just put the brownie dough and you let it cook and in one pan. So I thought, well, I'm going to spread the plastic in between the plates, and it was an epic fail. I think this is one of the pieces of the brownie approach. Sorry, the video's not great. This is one of my field strength meters. It's about 6 inches away and it's showing a negative field. As I bring it closer to the sensor, it increases the field strength. But these are some of my weakest, so nothing exciting there. So I'm using the grill now to have the polymer go into the glass phase. There's a actional copper plate under this, so I'm actually using the smaller copper plates to polarize the plastic. This actually works pretty well. I have a lot of non-conductive jigs that I use. Here I'm using this piece of wood that I cut and sanded smooth to pack the plastic because there's air holes, and air is the enemy of electrostatics. Air and humidity, they're the enemies. They'll bleed off your charge. There's the brownie cooking coming out the sides here. And yeah, it was a mess. But I still cranked thousands of volts in it and heated it up as hot as I could, and I learned. This one was strange to me because it stuck to the top and then it formed this tree. Now, this was one of my worst electrets, so nothing cool to say about it. But plastic seems to work in fractals. This sort of looks like fractals to me. Thought I'd share that. There it is. Very strange, peculiar. Here it's coming up to the meter. It's got 20,000 volts, which is exciting, but an hour later it was gone. So sometimes there's just what's called a contact charge. And that is if you pull 2 things apart, it has a big static cling to it. You've seen that socks and pulling them out of your clothing dryer. The socks will stick, and then pull them apart, they'll have that crackling noise. That basically is what you saw there. It was a high voltage, but it was gone in no time. This burnt piece of plastic here is one of my strongest electrets, and you'll see it later in action when I test it. These are some of the molds, and these are some of the plastics, and I'm just constantly trying new things. This was like a bar of a certain type of plastic. Its name is POM. If you look up POM, that's the plastic in here. And it's another word for it is acetal. And the regular plastics I use are polypropylene or polyethylene. And polyethylene I'm having a lot more luck with. And those are those candy molds over there that you saw that I'm going to be using. All right, so they are in the cooker. I'm maxed out the heat, and you can see that the arcing from the top plate to the bottom. So you can see I'm pumping tens of thousands of volts into it. And again, the heat is supposed to really get the atomic structures, the molecules in the plastic to sort of move around, if you will. And as they move in the heat, then the electric field says, hey, you need to point toward me because I'm positive, or vice versa. And so this is an example of one of my setups. And I'm always watching the humidity. So it's 34% humidity. I know it's a lot less humidity inside there with the heat, but it's just good to know the area, the surfaces I'm working with. I put some kind of weights on here. That way it keeps the pressure, because I'm really wanting to get into pressure to add to the heat, vibration, the electric field, all of these things to come into play. I'd like to add pressure. So I'm working on that. It's going to be in the future, but these weights help. Now you can see that this is my first batch, and they look horrible, but they actually worked. And that thing is probably, it's my second worst electret right here. It literally had no charge. It was a piece of junk. So my first electret, ziggurat. And you can see, so trying to mix plastics together is very difficult. This is usually what you end up with. So it just takes some learning. And I've been getting better each time. So let's see what I'm doing here. Oh yeah, so these plastic pellets, when they get in between these weights and the heat, they form these structures under the electric field. So I thought that was really interesting. Those weren't there. The metal was perfectly clean before this. Showing you the whole setup. There we go. And I've got a full load, so it's 4 plates. The voltage actually travels across the aluminum tape on the top, which is pretty cool. So I've got circles, discs or hockey pucks, and ziggurat molds. Again, here's another setup. Okay, so here I'm doing something that didn't work, but I'm pretty bummed about it. I'm gonna try to get it to work. I'll show you here. Let's see. Right. So if you'll see here, the red is up from the upper left corner. This red wire is the positive. And of course, the other side here is the negative on the bottom plate, the bottom copper plate. But what I've done is I've grounded out the top, the red wire. So now instead of having 0 volts to, let's say 100,000 volts, now I have 0 volts is the highest, and then 100,000 negative volts. Now, I have some ideas of why this didn't work, so I'm going to try this again. But I really think this is going to do something amazing in the future. But I had some problems with the electret with this experiment, so that's why I need to revisit it. But it's very fascinating. You might want to look at that when you're developing an output of high voltage. What happens if I connect the positive of the high voltage to ground? That means that the negative and between the positive and negative, it'll be all negative energy, all negative volts, all negative amps. So I thought I'd share that. It's a pretty cool little trick. It's not going to hurt the power supply. All the power supply cares about is, am I giving you 100,000 volts? And so whether it's negative or positive, it's incredible. It doesn't matter. Here, I took off the 2 prongs and just kept the ground prong. I don't know if you guys have done this before, but this allows you to plug into any outlet and then snag on the ground part instead of rigging something up more complicated. Another setup. I space these out a little bit more, and you're kind of seeing the brightness of this is 10 times brighter and louder in person. But this is showing just how tough and mean some of the electric fields that I'm working with. Let's see. Now we're in the making phase, so we'll get to the testing here soon. But I'm using these little Reese's peanut butter cup to hold up these different shapes. And so I have all kinds of different shapes. I have all different kinds of plastics in this one. So the one here that looks like a cat turd, I was basically going through our recycled plastics and throwing them in these slots, and just to see what they do. And this one, the one that looks like a chewed up rotten banana, that was oh boy, it's the plastic they use in binders for paper binders. So yeah, epic fail. A lot of this stuff fails, but it's fun. These I had big high hopes for the spheres. They don't work in this setup, but the spheres do work when I put the wire down in the middle. And so I've only done that once. It works, but I'm going to set up where multiple wires go down the middle. Now, tinfoil is very important to this process. The reason for that is right now you've moved the positive sides, the proton sides to one end, and you've moved the electron sides to the other. And so right now they're trying to coax the other molecules to join them. Now, if you leave it in the air, what happens is the air is going to pick off all of those charges from the surface. So now you don't have any help from the surface charge. But if you put aluminum foil around it, what that does is it shorts out the charges, therefore protecting the surface charges and actually strengthening the method of the molecules actually getting to where you want them in order to make a permanent electret. And so that's the reason. And so what's really cool about this too is I'll wrap these up in tin foil, and then an hour or two later, I'll pull them out. They'll show 10, 12,000 volts. I'll leave them out for about an hour. They drop to about 3,000 volts. I put them back in the tin foil, and then a couple hours later, they're 12,000 volts. So that's really, really cool. It's really necessary, to be honest, if you're in your garage making electrets. My guess is if you're in a high-tech lab, maybe there's a workaround for this, but this is the poor man's electret aiding device, very high-tech tinfoil. So you can see I'm getting better at making a full one of the ziggurat here. And when it gets these little charred spots, I thought those were the enemy, but as I'm finding out, and Brent Jarvis pointed this out to me, and he sort of just planted the seed in me that, hey, did that get carbon on it? And I basically was trying to avoid it, but as I got more carbon, I found out that the electrodes were getting stronger. So this plastic it's a single plastic, and then it's mixed with this powder here, and this powder is Teflon powder. And then I put it under the techniques that you saw earlier, and then right out of the oven, I put them immediately in aluminum foil, and then after a little bit, I start testing them. There's a real up close. You can see it. Teflon doesn't like to mix with anything. Teflon is the devil to work with because if you have this nice, soft, pliable plastic and it melts nice, it charges up, it's beautiful. And then you get this Teflon and you mix it into it, the plastic becomes or takes on the properties of Teflon. Teflon does not melt. Teflon is hard as a stone, rock. Teflon is some tough stuff. So it's sparse here in pockets here because it's tough to mix. I think I've come up with a way to fix this, but that's why you're seeing these little clouds, these little white clouds. Even though Teflon is the devil, it's also the most powerful plastic to charge. So I'm getting my best charges using Teflon. So it's a love-hate relationship we have. Here's the original picture that I shared with you. So now you kind of have an idea of pouring the plastic pellets in and mixing the Teflon, putting them under heat, and all those other stressors. It's another top view. This is version 2 of my setup. So I have version 3 that's coming. And I think you guys will find it interesting. Another mess. So this is always, it's worse than cooking. With cooking, you sort of soak it and the dishes are clean by scrubbing them. Here, you have to use heat, and you have to use a great heat and with putty knives and scratcher pads. So it's always a mess to clean up and get ready for the next set. And look at this. This is my next batch that came out really clean, really nice. And let's see how they test. Showing you guys more of my messes that I have to clean up every time. You can see the toaster oven. Okay, so one of the biggest challenges is consistent heat for the Electrets. So trying to manage that consistent heat, I thought, well, you know what? I'm going to drill some holes into this toaster oven that's all metal. Then if you can see over here to the left, this is the ground wire, the negative wire from the power supply. And here top is a whole jumbled mess of silicone, baking silicone that I formed into this this sort of insert. Now I can lower the positive wire down onto the positive plate, and now I can zap the plastic while keeping a very thorough and complete and consistent heat. And so to me, this was going to be the biggest win because consistent heat has just been a constant problem, even with that lid. So here you go. I've triple padded the wire to be heat resistant. And here that's the positive dropping down. And we're going to get ready to make some Electrets inside this. And you can see now this is my tests. It's creating some beautiful plasma in there. And now one of the tricks is that this thing's all metal. So in order to get the metal to only stay in this one little spot was very difficult. It looks easy, but it was not easy. So now that I have this controlled plasma in the center of an all steel container, maybe I can harness the strongest electric field to make the better Electrets at consistent heat. So there you go. It's got that beautiful plasma discharge that I like. There's the silicone molds, and I mean, I was so excited about this. This was a big win for me as far as upgrading my lab equipment because they don't make stuff what I'm trying to do. So it's basically the thrift store and what's laying around the garage that I have to use. Okay. I think this is just similar to what we've seen before. Let's see. So I'll use either bake or toast. Broil actually burns the top. If that's really that important. Again, I'm cooking some more. Here's some more. Appreciate your guys' patience. This was just all download or uploaded from my phone, and during the past month, and So I'm just catching you up on what I was doing in between my bouts of health. This is what the arcing and sparking looks like uh, when just the two wires are put together. I'll show that here in a second. So I'm just kind of showing you how the positive wire just dances here on the top of the scored by sandpaper copper plate. There's another picture of it. Here it is in the dark. I'm watching my true crime channel, TV channel. So the entire case of this toaster oven is ground, and only the top plate is positive. And because of that, that was ended up being an epic fail, because the ground needs to be straight on the bottom, and then the positive needs to be straight on the top. Here's one of my high-tech methods of mixing powders and pellets. So the powder you're seeing here is is Teflon, and the pellets there you're seeing are polyethylene. And so after you do this enough, the pellets get so covered in Teflon, it's a matter of then just them rubbing against each other. Each time I do this, I'm adding thousands and thousands of volts from onto the Teflon. So that's what I call the pre-charge. It's actually Brent Jarvis's application, patent applications word. It's called the pre-charge before I get into charging it. Now I've learned over time here that I have to overstuff the molds, because otherwise when the plastic shrinks, removes the air pockets, then you won't have a nice mold if you don't overfill them. So this is kind of how I start my messes. One of the nice things to keep the silicone supple and easy to work with, also to keep to reduce the oxidation on your copper, is Vaseline. Vaseline is sort of the use it everywhere, inexpensive product. All right, so we're going to start testing now. So here I just pulled this out of the oven. It's over 22,000 volts. Now these Electrets are, I think they're my best. I think there's only one better Electret, but fresh out of the setup, over 22,000 volts. That's very promising. Here I'm trying now different geometric shapes, different plastics. It's so messy. I'm not very coordinated. Also, I have tremors and shakes, so it's okay. Oh, back to the grinder. If anybody knows about grain milling, it would be great to know what kind of grinding plates that I can put in here that might be good for grinding plastic pellets, because I'm pretty sure these rock plates are not working for plastic, because every time I put it in here, the plastic melts. So, but I just started, so I might figure it out. This is wax from a palm tree. And what I wanted to show you guys is I was trying to polarize the wax here between these two plates. And what I noticed, if you look up here in between the plates, there's these ripples. And I couldn't, this is the best I could get under here, but these are pillars of liquid wax. They're almost cylindrical. And they would, as the voltage would increase, they would just form sort of this palace of pillars in the wax. And I just thought it was fascinating. So, and the wax would jump up in that formation as this was sparking. And how did this work? It held a light charge. It was a respectable charge, but it's not the charge that I'm looking for. I want a charge that does work. That's my goal. A charge, an electret that does work. Here's Teflon powder. If you ever thought about a powder that gets everywhere on anything and everything, that's your powder. But here it is it's a dream powder. I told you it was a love-hate. If you rub it on anything, it becomes nonstick. Now, you know this when you cook on nonstick pans. I didn't put it together till later. But yeah, my cleanup was way better after I learned this little trick. Finger rub everything in a little bit of Teflon powder, and everything becomes nonstick. Here I was trying to get higher voltages, so I put the positive plate and lid, and I'm cutting out the bottom here because it's always good to get the plastic touching between the plates. The closer you have to the plates, the better the electret. Oh boy, we're going long. We're almost done, guys. Alcohol is your friend for resetting everything. So if you wipe silicone, you wipe your plates, everything, it resets. It makes it really dry, so you need the Vaseline. But alcohol, isopropyl alcohol is the best. Here's my messy lab. I think I'm going to show something here. No, I just think I'm showing you what I'm doing. Yeah, this is my setup. So I sit here hours a day, and you can see my garage is quite a mess. And yeah, this is my area. This is a little bit more. Oh, those are the discs. They were a fail. I gotta get through these. I apologize, guys. I thought I'd get to the testing here quicker. Let me skip to the testing here. So this is a lamination machine that I picked up from Amazon. I thought, why don't I just put different plastic materials and laminate it and then shake it and see if it has a voltage? And it actually ended up pretty cool. Here it's coming out. So if you have a laminator and you're bored, run powders through it or glass beads and shake it. You'll get a voltage. And so here I put some glass beads there, and then I run it through the lamination machine. I have a lot of material. Oh my goodness. We'll get through this. Thank you guys for your patience. So what I do is I ran them both through 3mm, and then I combined them and under 5mm. So now I have a positive, which is the glass, and the negative is the Teflon. During the testing, you'll see how they work, but right now I'm just focused on making, which I think I'm going really long on here. So let me get to the testing. Let me get to the testing. Let's see, more making. This is something I have to do too. That's an electret that exists, but because it's humid in my garage, I have to bake it for a little bit, and then I put it in a plastic bag. Otherwise, your electrets are going to suffer in the humidity. So that's a trick too, is you got to kind of bake them and put them in tin foil, then put them in the plastic bag. These are the main meters that I use. The meter on the left gives you the voltage. A meter in the middle gives you the field intensity or strength. And then on the right, it's a multimeter plugged into the field meter, and it gives you a quantitative representation of the field voltage. Yeah, if you understand what I just said, please tell me in the chat, because I don't. Okay, now I'm wanting to test these and to get them to see if they can do work. And you can see here that this piece of plastic, this electret, it's so powerful that it causes this needle to just slam down. So this is how I know I'm on the right track. I'm really charging these things. So that's some work. Here I'm placing it on the electrostatic meter, these burnt pieces of plastic, and showing you how that they are getting charged and they're getting really high voltages. This runs in 10 to 22,000 volts. Pretty incredible. That's the field, E-field meter. So this shows you this is very weak. But it kind of shows you how it works. And again, I'm bringing an electret closer and further away. And this is giving me the E-field strength, the distance to E-field. I put these spacers on here because if they're not at the right spacing, it's not the right voltage. So these are sort of my training wheels. And this E-field meter is just awesome to use because I want to see how far the electric field is from the electret. I have electrets that have 3-foot radius electric fields. And this is the meter that will tell you that. And so if you can feel the electret at 3 feet away, that's incredible. So that's why this meter comes into play. It gives me that sense of field strength. And this is a close-up, negative and positive. This is the ground. So if I want to reset myself so I'm not becoming part of the circuit, I always grab my ground and then I get the correct readings. Let's see, let's get to the juicy parts. I got to skip through this here. Let's see, this is one of my spheres. Remember that turquoise mold? And it got some charge. It wasn't nothing to write home about. You get about 10,000 volts in this little round piece of plastic. Now this is another device I use. It's the rotary electroscope, and it's basically an aluminum rod bent at both ends, and it sits on top of on a needle on a steel stand. And so this has been really good because I don't want just a bunch of plastic to show up on meters. I want plastic to do work. So I'm never touching the plastic to any of this. It's strictly the field that is drawing the aluminum rotary bar here, this rotor, and it's drawing it by the sheer energy of the field that has been placed in this burnt piece of plastic. So they're getting to do work, and this is what's really exciting to me. This is one of my little electrostatic meters. This little sweet blue flame that makes no noise, the big one does it as well, but it's about 4 inches across. So again, this is not your dirty, nasty DC that the Marx generator is going to give me. This is more of a refined, clean, yeah, it doesn't even put out ozone kind of arc. Testing fields, polarity and strength. So I'm kind of showing you how it goes together. These are kind of funny. You can Google them. It's called a rotary electroscope. A rotary electroscope. I got this on eBay. They wanted like 25 bucks or 30 bucks for one of these, and they're well made. But I found another place that sold 15 of them for about 80 bucks. So I thought, well, if I bought two, it'd be, 75 bucks, or I could buy 15 of them for 80 bucks. So I bought 15 of these guys just to save money, and they're great. So I have them everywhere for testing these. This is one of my best electrets because you can just see that the field is so strong that it can get actually some speed to this. Now you have to be really coordinated because I haven't designed a better apparatus than my fingers. But you're getting the sense now that look at that, it puts the brakes on this rotor and then it brings it to the other direction. So we're seeing some power now, some usable energy within these charred pieces of plastic. And that's exciting to me because I feel like I'm on the right path. Let's see here. So I'm going to test the ziggurat, and I think it's one of my first ones. One thing about the ziggurats that was interesting too is they tended to have the strongest field on the pointy part, and then on the sides they had slightly less strong fields, and then at the bottom had the weakest field. Now I thought for me the bottom should have had the biggest field because it's more mass, but it's actually the opposite. Now I know you guys are going to say in the chat that the tip is stronger because the energy is more condensed, but I just can't wrap my head around that because I feel like there's way more matter at the bottom of this, way more charge. Why isn't it stronger? But no, the bottom is always the weakest. The top is usually the strongest. And so you can see I'm testing these ziggurats, and the the bottom side had to go far. So I test each side, and because I'm not consistent, because I don't have the equipment, these mixtures provide very um, they provide a dependable voltage, but it's not in the same place exactly, and it's not the same strength. But as you see, they're doing work, and that's what's important, because that means that they're really, there are possibilities with them, because they can do work. Let's see, more testing. Let's see. And it's just, it wants to try. It shows you kind of, a lot of my electrodes do this. They just don't work. And here we're kind of seeing something different because it's stronger on that one side. But again, it's so fascinating because this is not a ion wind. It's not magnetism. It's just sheer electric field that every molecule of every atom has, and yet it's being manipulated here to control this rotary and perform work. It's pretty incredible, especially when I'm pulling these ziggurats out, and they're a week, 2 weeks old. So if I wasn't getting a charge in them, why is it lasting weeks? I have charges from April, so I'm on the right path. I think this is one of the spheres that actually worked. I think the rest of them didn't, but you can see this sphere works, and not as I guess this is a decent one. I keep bumping it too. This is a disk. More and more testing. I'll write down my numbers. I'll package these back up in aluminum, and it's testing, testing, testing. Let's see, another charred, burnt side. Again, and these are all different electrets. So let's get to some, it's another sphere. I think this is, so this is my life right here, right here. Right. No, wait a minute. This one's actually better. Oh, yeah, this is my life. Most of them, 90% of my experiments don't work. And it's because of little mistakes that I've made. So I'm learning. But yeah, so as I hone my skills, the better they get. And that's life, right? So, but pretty cool. Spheres on it. And this is another disc. Yeah, so again, pretty cool stuff. I can't wait to get these stronger, then stack them, and then be used as a power source. It's kind of one of the end goals. I know Brent Jarvis is so creative. He has so many ideas. I'm just his grunt, making Nikes in the basement. Let's see here. This is ziggurat. And they're just getting stronger as I work with them. So each batch gets stronger and stronger. I'm just pulling them out of the oven so fast I couldn't even get it out of the way. Yeah, it's pretty awesome. And I've been working on a motor. Jarvis actually sent me a really cool motor schematic, and we're both on the same page. Here I'm showing you that's about 18 inches. You can see the field. So ziggurat's doing pretty cool. Another ziggurat. I think this one's another 18-inch field. Yeah, maybe a little longer, maybe 2 feet. Look at that. That's incredible. This is one of the motors I designed. I connected it to the high voltage power supply. This is just a light bulb that I took the guts out of and put it on a pointy thing. And I had fun with copper tape. Here's another picture of it. You just put in 1,000 volts and this thing just goes crazy. Let me see if I have a, it spins for minutes. Oh, I wanted to show you. Let me see if I can do this. Yeah, okay. This is how I put the copper tape on the light bulb. I cut it in strips, spaced it out, and then I put the light bulb on top of that pointy thing, and then I put, the wires don't touch on each side. The wires are about a quarter, eighth inch away. And so my hope is to connect a powerful enough electret on each side at different polarities and then to get this motor to run. It's kind of the plan. Some of the materials you're seeing here that I'm working with already have a charge by just jiggling them a bit. This is a powder. It's called a ferroelectric powder. It's very special stuff. I got it from Istanbul, Turkey, from a little chemical factory there. And this is gonna, I think, take me to the next level. Okay, so here are the materials I used to make the electroscope. I'm sorry, the electromotor. But that ferroelectric powder, I think that's going to be the next step. I think that's going to be the next jump. The next level. Just kind of showing you how I hooked it up. Spins forever. So this was a mess. This actually caught fire. I was so embarrassed. I was going to throw it in the trash, but then my wife gave me flowers, though. She's sweet. So, and then I thought, well, let's see, does it have any charge? Well, I mean, it's a burnt hockey puck, but it's got something. So I thought, well, I'll put it in the bag, I guess. The burnt part is the actual PVC pipe I put it in, and because I just had the temperature too high, and I just put everything the maximum voltage. I didn't care, and I did it for 15 minutes until it like smoked, and so yeah, so it did a little something. This is just another. It's getting repetitive. They're just getting better. I made a super tiny motor, so I'm going to be using this first. I'm going to try to get this powered by Electrets, and then I'll share it with you guys. But I just built that. And remember those discs that I heated up? They lost their charge after 2 days. So this is day one. They weren't worth watching. This is what I ran through the laminator. Here's my control. So nothing. Gonna shake that laminated paper. I'm trying not to blow it. So just trying to make sure that, see, I'm shaking it. And now I'm going to try. Doesn't move the armature. And there's that laminated glass and Teflon mess I made. And yeah, if you have a laminator, you can do this. It only costs like $20. And look at that. It's a hand shaking electret. And if you shake it a little bit, I'll tell you, you can get that thing spinning so fast you can't put it in. So this is based upon one of the patent applications. I'm not touching this, believe it or not. This is what is called the pre-charge that Brent Jarvis was talking about. This is another example of that. Let's see, almost done, guys. This is a whole new, different kind of plastic mixture, whole different molecular makeup. Again, I'm testing it. I'm using my 3 meters. This is the electrostatic. What I'll show you with these things too is how they what's the word? They lose their charge. They're like a battery. They'll just, after a while, they'll lose their charge. And then I put it back in the aluminum. They get their charge back. And so I'll run these tests. This material is so good, this plastic. It's polypropylene. It holds its charge the longest. So it's a very promising material. Even the scraps, of the plastic, they end up being some of my best electrets. And this is something that drives me crazy. My guess is because it's so thin and under pressure. Look at that. It's over 22,000 volts. And these little shavings will actually power that rotor. So I end up putting all my plastic shavings in aluminum just to kind of see what I'm going to have later. So that's another discovery that's fascinating. Even my mistakes work. Talk about that. So, again, I'm doing this is another laminated paper. I made another shaking electret with the glass beads and the Teflon powder. And I was so excited. I shared this with Jarvis. And again, here you go. Let's see if it works. And yeah, it's crazy. And I can get this thing spinning quickly too. But for the sake of time, let's see if I can get through this. Same thing. Same thing. Different, but same. Yeah, these shake 'em electrets are pretty incredible. Oh, here's the burnt. Here's that burnt one. Look at this. This burnt one, a day in the aluminum foil. Remember how it's kind of weak when I pulled it out? This is the next day. It's my strongest electret, the burnt one. It's so crazy. I almost threw it away. So what I'm going to do is I'm going to go look at my notes and figure out what I did to this burnt one, and then I can make my next batch better. But that was pretty incredible. Again, the burnt one's so fast I can't even almost move it out of the way. That's so cool. I'm going to be making some burnt ziggurats here. Let's see, I'm just watching a discharge more. All right, so I took some cool pictures of what my electrets look like inside, close-ups with some light through them. There is an aesthetic quality. They're really cool to look at. I think this one's my coolest picture. But this means we're close to the end, guys. Thanks for hanging in there. All right, this is 2 weeks. In the aluminum foil. This is, I think, my last video. Take a good look at it. Isn't it pretty? And did it lose its charge? No. Ooh, look at that. No. These electrets, these ziggurats are incredible. They get stronger and stronger as I leave them into the aluminum foil. Yeah. Look at that messy, splotchy piece of plastic. And that concludes my presentation. Oh my goodness, guys, I went so long. Let's see here. You guys still see me?
Yeah, I can see you, Shawn.
So what'd you think?
Dude, that's awesome. Got BurnEye here with us to see when he comes back. Yeah, that whole thing was awesome.
Did you get a little bit closer to what I was doing? Do you feel kind of maybe it wouldn't be so so what's the word? So difficult to try?
Okay. The shake and bake, the laminated stuff, dude, you got me there. That's the one I want.
Oh, it's oh, thank you, Crypto. Thank you, Paul. Oh my goodness, Vortec, you're awesome. Bordy, Yanni. Oh, guys, I'm overwhelmed. You guys are so amazing. Ulysses, all kinds of names I can't pronounce. John, Ugenzi, Ugensai. Thank you, guys. You guys are so wonderful. I'm so glad to share with you guys. It's been so long. I appreciate it. I hope you guys learned something. Thank you, Ricky. Yeah, wow, lots of love, guys. Limited state. I wanted to make electrets accessible, and the only way I could really do it was under Brent Jarvis's leadership and his help. And also, we had a talk, I think it was yesterday, about what we can share and what we can't share. And we decided to just lift the lid and show you how the sausage is made. And that way, maybe you guys can replicate it and we can build these together. I mean, you can go to the thrift store and pick up a hot grill. I can tell you what plastics to buy. Thank you, Ian. And then you can get a power supply, AliExpress or Amazon, and you're up and running. And yeah, it's incredible. that they're getting stronger and stronger. And I really believe the ferroelectric material, it's a nano crystal cubes that I got from Istanbul. I'm waiting for another special ferroelectric polymer. And in combining those, I should have an exponential effect. And so these should be then running as self-charging capacitors that you can pull out of the aluminum foil and have them do work during the day and put them back at night. And so I think we're on the track for getting there. And so I appreciate you guys. A little, yeah, stop burning oil. Exactly. Turn into electrets. Yeah, this the electrets are made out of plastic, which are basically made out of fossil fuels. So instead of burning fossil fuels, let's charge them. Let's fill them with electricity. And so I think the sky's the limit. And yeah, let's, I guess, get to some of your questions first. What do you think, Nathan?
Dude, I'm blown away, Shawn. You got so many cool things over there, man. Let me tell you, your thrift store is the best thrift store on the planet. I can tell you that. That's for sure. But know that meter that you got, the distance far and away, and you check it, dude, and that's so cool.
Yeah, that was a rare find. Nobody's doing what we're doing, so nobody knows what to do to either measure it, or so you sort of have to use like the unconventional tools are the toaster oven and the smokeless grill, but also some of the meters that are used for doing physics demonstrations at schools. And so yeah, it's sort of a conglomeration of those things. Let's see. Oh, Vortex says that ferroelectric materials were very important. Faraday worked with them too. Yeah, I feel like Faraday is a kindred spirit with me. We're very similar. We're both self-taught. We both came from nothing. We're relentless experimenters. He's a devout Protestant Christian. I'm a devout Protestant Christian. Um, and he just got excited about everything. And he, of course, we have the fair ad from the capacitor, but he had taught us so many amazing things. Yeah, I just always feel special closeness to Faraday.
Right on.
All right, so let's go to the comments, guys. If I missed your question, please feel free to repost it just so I can catch it. But some good stuff here. Thank you, Karma. Thank you, Straight Dope. Joe, you're awesome. Let's see. Vortex says we will rip the patent. Yeah, we're working on that patent, Vortex and I. See, John Brigham says it's weird when me and La Pointless were working on the crystal battery, we saw recharging if we direct the shorted cell. So sort of similar to me shorting out the electrets. He shorted out this design of a crystal battery, and he found it self-charging. That's my guess. Crypto, perfectly said. Stop burning oil. Turn into electrets. Yanni, far out. Thank you. Boy.
There's one here for you, Shawn. Have you tried curing with pulse DC only?
No. The DC that I'm using isn't the cleanest, but it's not a pulse DC. I ran through almost a dozen different high voltage power supplies, and they die easily. They're just garbage. And I'm not going to spend a couple thousand on a pulse DC. So that's why I picked up the Marks generator, the death machine, because it'll give me a pulse DC. That burnt PVC charred disc at the end, that one was only charged for 15 minutes. All my other electrets were charged for hours, and then they cooled down for hours.
The question on that one was, is it the carbon content that you're putting when the black gets on there?
That's what Jarvis believes. Yeah, he says there's a connection there. But also too, I just went total Nathan on it. I fried it and found out. I literally cranked everything and just watched it burn. And it's my best electorate. So so I haven't tried a pulse DC yet. And the curing, that's a good point. Tempura. Because I believe the most transformation occurs as it's heating and as it's cooling. I really believe those are the two big points. So when you're talking about running it intensely while it cures or while it cools down, I feel like that has a significant effect, is leaving the power on while it's cooling and curing.
Mm.
Another question, amorphous cores? Amorphous cores, have you heard of that?
No, I haven't.
I'm sorry, Tempura, I haven't heard of it either. Yanni says, epic cheers, keep safe, thank you. Vortex says Amorpheus could be carbon or other. Okay, so Vortex would know. Joe says, yeah, carbon is pretty good for high voltages. Yeah, it's interesting. Oh, Vortex says carbon has many allotropes. So, yeah, I've never heard of that word before, but yeah, very cool. Let's see here. Vortex says, link me.
Yeah, I was going to ask you, Shawn, is it cool is if he comes on and you guys talk about the patent? I want to give you time to answer the questions.
Oh yeah, I'd love it. Yeah.
Okay.
And I hope the chat's okay with it. Yeah, of course.
Oh, of course they are, man. They love both you guys.
Yeah, Jarvis is the guy. I mean, if you have everything question Electret, man, he is the expert. I'm just his one-eyed humpbacked assistant.
Yeah, don't ever go there with us, Shawn. We all know better than that by now, okay? You're like
I'm
the
your
brains of the
assistant.
operation. Let me just tell you that. We
Oh
know.
my goodness. Oh my goodness. Did you send it to him, or do I have to send it to him?
No, I took care of it. I sent it to him right now.
Okay. No, I'm intimidated by being the dumbest guy in the room, but I learned so much from you guys. It's totally awesome.
Yeah, we don't buy that, Shawn. We've seen your work. We know better.
Oh my goodness. Yeah. You see me burn plastic. Let's see. John Bigman says we have carbon in our bodies. That's interesting. Yanni says Jarvis is awesome. Yeah, he's okay. Bigman says water and carbon.
Yeah.
About that. Interesting. Crypto says, Shawn, you clearly have 2 hours.
Yeah.
What does that mean? Sorry.
Oh, you have all the time in the world, probably what he's saying, but I know you have a time
Oh,
limit. So
I appreciate that, Crypto. I didn't want to bore you guys.
you always say that. Look, let me just tell you something. When you come on, it makes the show, Shawn. Okay.
Oh,
That's why you run your own show when you come on. You just do what you want to do because everybody loves it.
Means a lot. It really does. I appreciate it, guys. With my PTSD, being around so much love, it really helps me. It's therapeutic. If I'm being honest, it really is. It's healing. So I appreciate that. Thank you, John. Darren says, let's go. Yeah, let's stop talking. Let's start doing.
Well, that's kind of what the channel's about, isn't it? Everybody comes on doing something. So everybody gets to learn a little bit, get to work on projects.
Yeah, exactly. I'm hoping that I can be that person who you can learn from all the wrong ways so you can get the right way. Because I'm sorry, I'm looking for your channel here on my iPad because I can read the comments better here. That's what I'm hoping, is that we all learn from each other's mistakes, because when people look at your Slayer circuit and they go, oh, that's so simple, just put a fan on it, right? And grab any transistor and, throw some wire around a PVC pipe. But they don't really have a clue that it spent hours of trial and error and learning and because it looks so simple and it's so powerful is because it had the effort put into it. And so,
well, yeah, because there's not a lot of information on the PNP circuit. Most of it's all NPN. No, nobody knows to run it backwards. Yeah, what's up, Jarvis?
I thought it was funny to say PNP is kind of pimp. PNP.
They're pimping my ride. Like, that's right.
PNP is cool. It matters.
It cracks me up because when I talk to Jarvis over the phone, I picture this guy in a suit and he's sitting in a big penthouse office. He's eloquent, brilliant. And then I get one of the brothers of ZZ Top. I go, I mean, I love it. I love the beard. If I wasn't married, I'd have a beard.
Yeah, I mean, I was forced with literature and everything. It's good to have proper English and everything, but when I chat, I do try to be proper. It's funny. It's kind of an OCD thing, but I'm not.
That's great.
I'm not a proper.
If somebody saw you, they would go, "Yeah, he works in construction. He's
I can see that."
I mean, not that construction's bad; it's awesome, but they would never know you publish physics papers. Which is incredible.
But that's cool with me, because physics is so boring. Like, I feel like I get it, but I don't want to argue. I just want to do it, and the only people doing it are you guys. And Tim Tron really did blow me away. I think Tim Tron knows what he's talking about. Heliarch 2.
Wow. Did you see that one, Shawn?
I started it. Ever since Jarvis said that he was impressed by those two guys, I actually put it in my queue and started it before we talked today. So yeah, it already got my interest. I already got my notebook out because I was like, wait a minute, what? He said something. Oh,
I could hear it. They know what they're saying,
So check this out. I'll give them a free plug. Dude, Tim Tron's been doing this Tim's been doing it for like 30 years. Okay.
Yeah.
For a long time. And then
I can tell.
Yeah. Flint came in and taught him what's going on.
He's literally one of the only ones I know that's still doing this. Like, after Bendini, like, it started dying off. Like, Tim Tron is really like legit. Honestly.
Oh, he is. Well, the cool thing was, so check this out. They do on their Patreon, when you sign up, they give you one-on-one. So if you're in your project and you're trying to get the over Unity out of it and you need that last little bit, man, you sign up with them and they walk you through it. And they're cool to send you parts if you don't have it. You know what I mean? Stuff like that. Mm-hmm. Dude, they're totally working with people. I'm just going to say this flat out, dude. I'm so impressed with that. Like, there's nobody out there doing that that'll say, hey, I'll get on the horn with you and handle it.
Yeah.
Just imagine the confidence of setting that up. Like, if you want to be one-on-one, I will tell you how to do it. You can't do that without literally knowing how to do it. I mean, you'll be called out as you know what I mean?
Yeah. But
I know he knows what's up, I appreciate Tim Tron and Heliarch. I think they're one of the most brilliant presenters you've had. Elijah Attack is actually like really doing good too. And always Bog Irish Ian. Bog Irish Ian is like on another level too. And the whole group, like everybody coming together.
Yeah, Elijah's going to be here on Friday with Joe and I, kind of going over his progress. He was doing today, he's taking this light bulb and putting it between him and the ground, and it lights up. And he's got a circuit running in the room, so he found some sort of resonance point or something. I gotta ask him about it. And then, to be honest, man, we saw the same thing on another channel. His tag in the chat there is Thor, Thor. Dude, he did the same thing today, and he basically put two diodes on it, took an LED, and he put it next to his microphone, and it turned right on. Yes, dude, it was wild.
Dude, one of the, like, I think it was the first presentation I did with you. You asked me about this guy that used a similar method of that. you can pigtail two diodes together and make an Emermenko plug, and you can tell which direction the current's traveling. So it's a one-wire method. It's a one-wire method.
They mentioned that in the first part. He mentioned that, and we should be talking about electrets, but that caught my eye was
electrets aren't the end all be all. I want people to know it's very important and it's a fascinating topic, but it's not. It's important, but it's not. It's just like magnets haven't been, but the combination could be really cool. Is all I'm saying. It's not. Yeah. We're not. Yeah, it's important too, though.
Yeah, finish your thought, Shawn.
Sorry. No, good point. You're right. Jar. He has so many nicknames. When he said that if you're running cold energy, the way you can tell is if you run it through a diode and then you have to look at it in the infrared. And what will show you is that if the PNP junction in the diode starts to cool, it's cooler than the ambient energy in the room, then you have cold energy. And oh my goodness, that's when my notepad came out.
It's endothermic. Any endothermic reaction, like Tesla literally focused, and Philip hit on this with Faraday's live stream on League of Extraordinary Gentlemen. Philip hit on this. You want like a vacuum, because whenever there's a vacuum, say positive charge, if we imagine the electron as the mobile charge and you have a positive charge, it's literally like a vacuum that it wants to expand into. And if you take any gas and expand it in a vacuum, it's going to cool down.
Oh, it's about time somebody finally said it. The negative itself, when you put it in there, it's basically just a static field. That in itself has no heat. So it pulls like a vacuum through the system.
But the interesting thing about the negative charge being an electron is it's generally the mobile charge. Now, sometimes there's ionic mobile charges with battery separators and stuff like that. But, it's easy for people to imagine an electron mobile gas. Just picture it, and literally in the quantum mechanics, you call it a Fermi gas. You can model it as a Fermi gas. But if you compress a gas and you expand it, whenever you compress a gas, it releases heat. And whenever you expand the gas rapidly, it absorbs heat. And it's an endothermic reaction that happens at that point. So when you want to get cold, and that's literally what Peltier devices do. If you study the physics, they'll give you gibberish on how that works, but it's literally going through diodes, expanding on one side and condensing on one side, and expanding on one side and condensing on one side. So that's what that is doing. It's
diodes then in the Peltier. It's
similar to diodes. I'm just relating it to what we're talking about.
Sure. Very cool. Very interesting. I guess I would ask the question, forgive me for not knowing this, but what's difference between cold energy and hot energy?
It's
cold electricity and hot electricity.
It would be if I took this and aimed it
Is that the infrared?
Yeah. And then I aimed it and got a colder temperature. Then you're having an endothermic reaction.
Well, hold on. Let me get to the fundamental part. It has no resistance, Shawn. So if a field has no resistance, it can't build up any energy in there to hold it back. And that's the difference in negative and positive. The positive is pushing your amperage through the circuit, so it's going to have resistance everywhere it goes. The negative is pulling the voltage field through the circuit. So it's acting as a vacuum to it, pulling it through so the heat can't build up anywhere.
And you can never have absolute zero heat. There's heat.
Well, yeah, I know that, but the amount is less.
I'm agreeing.
Okay, but hold on. There is a case where when you get your circuit in resonance, the negative in the coil will turn it ice cold. It'll actually freeze it over. Okay. Let me just tell you that there is a case where that happens, but you have to have your resonance on both sides perfect. Otherwise, it won't work.
Incredible.
What I've experienced is this. He was an old presenter, but and I'm probably not going to remember his name correctly, and I wish I knew his Mark Bellinger. Okay, he did this stuff with relays, and he showed that the relay switch would literally freeze.
Wow, incredible. So how would I go about creating cold electricity? Like,
yes,
what would be a circuit?
What do we do when we refrigerate stuff? You need the rapid expansion, right? It's called an expansion valve. You need a phase change. You need to compress it on one side and have an expansion valve to release the pressure into an environment that will absorb the heat from that environment.
Okay.
Just like refrigeration, but refrigeration also has counter current exchange. That makes it more efficient. And that's where Tim Shawn and Heliarch get into. You know, because the counter current exchange is just the same thing. Just picture a refrigerator, right? Yeah. Whenever it goes through the condenser and releases the heat,
right,
it first goes through a counter current exchange, and then it expands rapidly into the evaporator coil to cool it. And then it goes back through the counter current exchange. Because
I know that
it makes it more efficient to have the counter current exchange.
Nice.
You know, so you're not. Most people think you just compress, expand. They don't think about the counter current heat exchanger.
That's interesting. Yeah,
because it literally cools it as it's coming in.
It's amazing. Wow. One of the guys in the chat, QUODTN, says cold farts are stinkier.
They're more dense. They probably linger.
Oh, yeah, well, that milk for hot poo.
It's like a fart cloud. Like, oh my goodness! If it were hot, at least it would like.
Bring me in for the dense farts, why don't you?
I was hoping you would.
Speaking of smelly topics.
Hey, that's all right. I like it. Right? So who's going to be the first to record themselves setting one of their dense farts on fire from an electric, right?
Nathan,
I could go there.
Nathan's a leader.
Man, I did the chicken wings. Come on now.
Yeah.
I'll give it a shot.
Hey, that's the perfect fuel for the fire now.
Yeah, he did put out fire.
Oh, wow. Oh.
What are you working on, Bernie?
Well, I'm working on a few things. I actually just put together a proposal for try to get myself some more funding so I can actually make it to Tesla Tech to present this summer, as well as to finally get some of my materials shipped to some labs that actually have the equipment to test it and prove what not just the monoatomics are, but what I suspect the hydrogen electric charged particles are, as well as the oxygen magnetic charged particles are.
Hey, if I may cut you off, Shawn, if you're feeling like you want to relax, like you can join chat. You don't have to.
Yeah,
you know what I mean.
I hate to interrupt. Thank you for that, Bernie. I'm on the edge of my seat. I can't wait. I'm feeling a little low energy, so. If you guys don't mind,
You did great.
No worries, Shawn, and absolutely great presentation, and prayers with you with your health. And I too have to go get going myself. I just was stopping in to say hello as I got another stream coming up in 15 minutes. But amazing work, all three of you.
Appreciate that. Take care, guys. Hey, take care in the chat. Much love.
Thank you, guys.
Thank you, Shawn.
Thanks, Shawn.
The crafter.
Thanks, Bernie.
Crafter is the man. Bernie, so 15 minutes. Do you mind if I join you?
It's a different sort of one, but maybe halfway through, actually. There is some occult stuff. So yeah, I'll send you a link for sure, actually. Do you know Paranoid American? It's going to be with Thomas, Paranoid American. It's not really the technology side of stuff. It's more just the occult knowledge. He was a.
I can go there too, though. You know,
yeah, exactly, right? And he worked at Disney. I call him my dark Disney source. So,
Nice.
yeah,
I'm down.
On that note, love you guys, and yeah, I'll send you a link, Jarvis, for sure.
Thank you.
Right on, guys.
Thank you.
Oh man. Hey, real quick, the patent, you said you go ahead and just let everybody have it, huh?
Well, like I said, if it weren't for people that believed in me, and if I think that Shawn would be okay with it, I would rip it, because I want to be the second person like Tesla to have something and give it away, you know. And the importance is understanding the other side of the coin. You know, we're just trying to open people's minds and let them know that there's just not permanent magnetism, there's permanent electric. And you know, it just helps people. And as long as Shawn doesn't mind, like, that was my original goal, was to just literally publicly, when it comes time, to rip it, because I think Tesla was a hero, and he ripped his patent with Wardenclyffe, you know.
Yeah.
And certain things belong to everybody, and all it is, you know, the method. You know, you can patent systems and methods, but the materials are available by God, everybody. And you know, the system I want to teach, I'm a good mentor, but it belongs to everybody. And I got to talk to Shawn about that, but I will rip it. I mean,
well, I'll just be honest with you right now. People like the journey. So if you started out small with just a simple wax one and show people just a general idea of an electric first.
I'm working in the background on stuff like that.
Yeah, that's what I'm saying, though. It's one of those things where it teaches people along the right way so that they learn why things are working the right way. And then you can, you know, decide on your patent later, but it'd be a great understanding for the rest of us that don't understand as much.
It's kind of either way, you know. I'm not in it for the product to develop it to its fullest. So if it takes investment to get this going, let's do it. If it takes me ripping it and saying, I'll teach you how to do this, I'll do that too, you know. So it's a fine line, you know, but I'm prepared to rip it because Tesla, it was like, shoot, what if I just like,
yeah, like I said, man, show people, you know, some of the tech coming up, and then you know, decide later, but at least get people going.
The series, I was thinking about calling it Magic Static Gadgets, you know, and just have a series of where, imagine there's this static thing like a magnet, but it's not a magnet. And Alchemist and the history, people don't even know the history. Like Electra was the first name for electricity, named after amber. Like, it was named after amber because you would rub the amber and it would have an electric field. All of electricity is based off this, but what we're trying to do is produce a permanently charged one, just like a magnet. You know, that's the difference. And it, you know, but it's been known in history. I think the philosophers definitely knew about it. And I think when I talk to BurnEye, he'll understand that too. Yeah, Magic Static Gadgets.
Well, like I said, hey, look, if you want to, man, show's
you
open
can use
for
it. You can use it for just what you can use a magnet for. You can do with electrics too. Once it gets to the point of understanding how they can be used, you know, because people just don't understand. Like I said, it's like a guy with a compass. Like, dude, what is this force? You know.
Yeah.
But
well, like I said, let me get it out. If you want to come on and show people that on the show, dude, you're more than welcome to. And I'll, you know, put it out and we can talk about it afterward like Shawn does, and you can present. If you want to get a series going, where you just show the basics of it and get people into it and how they can start. Because sometimes it's like $50 to get it started. You know what I mean? On parts that you can get anywhere. And it's not that intimidating. So the door's open, my friend.
You know, that I actually call this the Master Crafter, the Master Crafter composite. This is what Shawn was using in his videos, and I didn't want to say the recipe, and Shawn's disclosing it too. And I think it's right to disclose it at the right time. What we're really trying to do is just be in a position to teach it and get it out, you know. And if it takes investment to do that, or if it takes the strategy of just us teaching, no matter what, it's gonna happen. But people don't understand electrets like they do magnets, and it's a different world. And there's a lot of applications if you're just creative and think about it. That there's actually more applications than magnets, in my opinion. But I guess I'm probably gonna have to shift over to BurnEye real quick. Love you too, Shawn. All right. You want to come with me?
I'll let you guys handle it, man. I got to go cook dinner for the family, man. They got me on this thing, man. Ever since I went on a diet, they said, okay, if Dad's barbecuing all the time, man, then we want in, right? And, yeah. So,
awesome sauce.
Yeah. But, man, that was cool. Shawn did the Electrets. It's cool that you're willing to take that extra step. I tell you, it's a part of science that we need to explore more. And the more we do, the better off we're going to be.
It's just something that most people are unaware of, even engineers. I've been in the field, and it's cool to know something different, and you don't know where it can develop, you know. And it's really just, I wish everybody would be interested and try it, because it could make the world different. Yeah. What if we had magneto electrets? You know, I just see it being important, and I will rip the patent. I don't care about money. I really don't. Like, honestly, I want to rip the patent, but I got to talk to Shawn about that. But thank you for having me on.
Yeah, not a problem, man. Thank you for coming on. All right.
Do you have an outro?
Oh, yeah, I'm going to play it soon, man. I wasn't done with the stream. I wanted to check on a couple people.
Yeah.
So, okay. So I just wanted to, real quick, man, we had some cool things. Jarvis, by the way, thank you, man, for the donation, brother. I appreciate it. Ulysses, man, thank you. I appreciate that, man. So, and then I gave away 5 free memberships to the channel, man, today. So, hopefully that'll help everybody out, man. And then I wanted to go over real quick on my coil. So people have been getting these in there. Oh, dude, look at this. Ulysses gave 5 free memberships right now. Straight up, brother. Right on. Right on, man. Dude, that's awesome. They've been getting these coils, right? So check it out. The PMP circuit that I sent with it is extremely powerful. Okay. I'm lighting up stuff at 11 feet with mine at half the power. So
I was trying to tell people it's not necessarily the coil alone, it's the way you drive it.
Oh, yeah. So check this out. Let me just say this. What happens is if it's too close to the circuit itself, or you put your power source too close to it, the Slater exciter is a self-regulated circuit. So it takes everything that's in its local environment and it tries to resonate with it.
It tunes, yeah.
So what's going on is it's trying to tune your power source. So your power source, power packs turn off, power sources mess up. They'll basically go from a little bit of turning it on to boom, like you shove 20 volts in it right away. Because it's trying to resonate back and forth. It's a self-correcting circuit to everything in the room next to you. So,
and I'll say it's inherently on that primary instead of the secondary, a one wire type of thing, right? You see that, right?
No.
On the primary.
Yeah.
You get that? I know you get that.
I get it. I guess what I'm trying to say is with everybody, when they get them, please put the everything at a distance. Because let's put it this way. I pulled 11 feet out of this coil, hooked into another coil which just had a ground on it, just a number 2 coil hooked to a ground. I could pull probably 30 feet out of it. The problem was it started knocking out the electronics in my room. So my Fire Stick TV had to get reset 3 times in order to get it back. My computer had malfunctions in it everywhere. This circuit is mean, dude. It resonates with other coils.
You're like a broadcast station when you fire.
Yeah, it basically is. So that was, dude, it was at 20 volts.
It's like you want to like scramble, you could have like a scramble, like
yeah, dude, seriously. Like I said, it's 20 volts going in, man. It's all it took to do that.
Yeah.
40 volts going in is the max of the circuit. So it's a monster circuit. There's only 2 parts to it. I mean, it is literally a
transistor.
Brilliant. Yeah, and it's a resistor. That's it.
When it comes to a drive system, I'd have to say that's one of my favorites that you have done there. And everybody knows the Tesla coil, but the drive circuit is very important. And it's really cool what Nathan did there. Like, I know he has past videos, and I don't mean to say search through them, but he's had videos of showing the PMP and how to use it properly over at NPN, and most people choose the NPN, and it's really he does a bang up job.
They get half the power is what they're getting.
Yeah.
If that.
Yeah.
So real quick, Faraday cage, by the way, works great for AC Tesla coils. Okay. Where you get in trouble is sometimes if you're pulling the field from the center of the coil, it won't work at all. A Faraday cage is completely useless when you're doing that. It'll go right through it like it's not even there.
Yeah, sometimes, from the center. You use a brass rod too, right?
Yes.
Yeah, brass is cool.
Well, hold on. But the better way to pull it, okay, just so you know, is you have to take an insulated wire and put it down the center of it. Because it works harder to get in there to that wire itself through the insulation, it makes the energy colder. As it makes the energy colder, it makes it work better to pull the vacuum harder. Because you got to remember the inside's working on the impulse, the outside's working on pulse.
What would you think about taking the brass rod and spraying it with some acrylic spray or something?
Yeah, you could do that, but you're not going to get the insulation. You might as well just put shrink tube over it. You're better off just getting some
shrink tube would be good.
You work with some different insulations on the wire and change it.
Shrink tube would be good too. Yeah. I see what you're saying. You got like with the refrigerator. Think about it. So most electrical insulators don't conduct heat very well. Okay, but alumina is a very good electrical insulator that conducts heat. So these things can be used on the compression cycle to expel the heat before it goes through a countercurrent exchange, the expansion to the evaporator. You get what I'm saying? Like true cold current takes a process, but it's no more difficult than a refrigerator. If you understand the most efficient refrigeration cycle using countercurrent, it makes a lot more sense.
Yeah. So, check this out. I gotta say this too. Sorry. This coil, why it works so well? You see the primary on this, the plastic? Let me tell you this. This plastic is the greatest thing in the world. The distance between each one of them is set perfectly. Now, that's right there is half the game. Because each one of them represents a different area where it oscillates out, right? But as they're set perfect in a perfect oscillation circuit, these become the most important thing in the room. This right here and this right here are matched perfectly.
You got enough room if you wanted to alligator clip it on there. You could do that too. You know what I mean?
Oh, yeah. Well, I use a little clip that I built myself that works perfect on there. Goes hugs that thing perfectly.
you can go around the base and get it just in the right position.
Mm-hmm.
You left enough space for that.
Oh,
Yeah, I get it. I'm gonna like, I understand the engineering. Like, honestly, you're one of the best builders and you're one of the best group people. I mean, it's important to have a group, and I don't know. I feel like you're a good chief, man. You're a good captain. So I appreciate the platform you provide. You really help us get together, and brilliant people in chat, and everybody working together will get there. It can't be an individual thing. I believe. I believe everybody's just got to work together. We'll get there. It's a group effort, though. I think
so too, man. Look, everybody that comes on, man, gets to say their piece. I don't argue with people when they come on. I try to find common ground with everybody and just get to the point. You know what I mean? So everybody has it. And yeah, Tim was on me the other day trying to get extra information, right? Well, yeah, that's kind of my job, isn't it? But to be honest with you, man, that whole thing he did. So I had on Mike Faraday's channel, just shout out to Mike and League of Extraordinary Inventors. I had like 10 minutes to talk to Tim. And dude, it was like the most enlightening 10 minutes of my life. And then we had Heliarch was on several times with me, right? Talking about the Meg and stuff like that. And these two were together. And I'm like, okay, no, we got to do this, right? They asked me to call some other people. I said, no. These two only with me. We're going to get this right. And then, dude, it was a bomb. Dude, we did 4 hours. That thing was just amazing.
But it's so true. Like, I would spend a week trying to find the real deal. It's hard. Like, Bedini and all that was kind of the last. But like Tim and Heliarch are really the only ones that have progressed in that field that are publicly available to talk to. And even with their Patreon, it's worth having a one-on-one conversation with them. And like they even suggest, you might want to build a little bit first before you progress into the Patreon to have a one-on-one. Just get your hands on it, start building it. And once you get to a point, upgrade and ask them one-on-one. It's brilliant. And they're really can't find many other people like that. I mean, you are, Faraday is, and I'm not trying to exclude anybody from the group. This whole group is great. But when it comes to like the real deal, Tim is really the patriarch. Tim knows what's up.
Yeah, dude, I'm right there with you. So, yeah, right on, man. Yeah, if anybody wants to learn that circuit, man, the PMP, something like that, by all means, look up my video. Or if you guys want me to do another show on it, I'll do it. I mean, it's not a problem. It's fairly easy to understand once you get it. And it works sometimes differently in a battery than it does the voltage out of your wall. I'll just throw that out there. It's a different experience, let me tell you that. If you really want some cold currents going on, if you want some cold electricity going on, your battery works a bit different than it does in your wall plug. Wall plug's like drinking from a fire hose, where your battery's not, and you can pull some wild stuff off of your battery. Just so we know, it's a different. I think
it's endothermic when it comes to the throat material and even insulation and stuff. But it's an endothermic thing going on there, and that's a good first step. Is all I'm gonna say. Is if you don't get anything from it, just realize if something gets cold, it's probably absorbing energy. I mean, it's an obvious thing. You can go around with the heat gun and, hey, if this is colder, like, is it absorbing heat? How is it absorbing? And heat's everywhere. So whenever you get to an endothermic, it's probably where you get along the lines of over unity. I hate saying free energy.
Well, okay, so check it out. Anytime you resonate your system properly, okay, then you
got to phase it. You got to resonate it and you got to phase it.
So when you do that, things start to change in your circuit. Things flow faster. They work better. You get more power out of them. There's less resistance and everything. Spark gaps themselves start to give you a little bit of over unity in them because they're pulling in more energy from the surrounding environment. Then
it's like an expansion valve.
Yeah, you'll notice a temperature change in your spark gap. It'll go from 240 degrees to room temperature. And it does that because your system is efficient.
It's a brilliant way to learn about what we're saying, but it's not necessarily the best way these days to do it. You know what I mean? But to learn initially, a spark gap really has properties of cooling if you study how to do it. Yeah.
Now, hold on. I think there's some ways out there that are self-regulating that are way better than transistors and MOSFETs. Okay. And it has to do with the amount of energy you can put through them. Like a spark gap's a beautiful thing, right? A contactor is a beautiful thing if you understand what it's doing, and you can get higher energy out of it. So,
I would say what along those lines, Tim Chong kind of nailed it on the head. Having a magnet and spin spark gap, that's pretty much a high voltage, high current situation you got going on there.
But hold on, he told you he had magnets in between them, so he was quenching between each cycle. Yeah, every time it went by, he quenched it with that magnet. See, you got to pick up on what he says.
That's why I'm like, Tim John, dude, I know what you're saying, dude, and he just listen to him. He really did on that last time he was on with you. He said the real deal, and that's cool.
Yeah. Right on, man. All right. Yeah. Joel, I actually, I'm going to send Joel an email and see if he wants to come back on. Tim's actually a big fan of Joel. So, you know what I mean? We may have something in the future if they both want to do it together, but I'd like to have Joel back on because he's working on the Smith stuff and he's resonating coils together. You know what I mean? Stuff like that. Mm-hmm. Dude. Yeah. That
I know
right there is awesome.
I know Don Smith too. So Tim, I've been wanting to talk to you, and I will eventually. But Tim Chon, I think if me and you talk, like I know Don Smith. I'm not gonna say better than Joel, but I know Don Smith pretty well because I've studied a lot of Tesla, and it's a lot like Tesla. So hit me up. But the thing is, Tim would one up me. He'd be like, "Dude, I already know this too." You know, so it's pointless. Tim's a boss. I'm just saying.
Well, let me tell you what makes it great. It makes it great for interviewing someone because I just have to shut up and listen. You know what I mean? Yeah. Ask one or two questions here or there, and that's it. He's got the show.
Tim's the man where I shut up too and just be like, dude, Tim.
Yeah.
But it's a great show. I'm sorry, guys. I haven't received a BurnEye link, but I'll see if BurnEye's doing a live. Maybe I can hit him up in the live chat and see if there's something.
Yeah, it's all good, man. We're gonna take off here, man. It's been 2 hours, and Shawn did an awesome job today, brother.
Shawn did, yeah.
I love the fact that when he comes on the show and does it, man, just does his thing.
He does such a good job. I just think like a year on a provisional is a sharp curve, and that's hard. Like, you know, because a lot of people have to learn that, and he's just a brilliant guy, man. I just think he's amazing. He's the best partner I could ever ask for.
Yeah, dude, I agree with you. He's totally like on it with the Tesla with me, and takes care of me. You know what I mean? And it shows me things I don't even know. So, right on, man. All right, guys. With that said, man, I just want to thank everybody in the chat. You guys are awesome. Thank you for the great show. Thank you, Shawn. Thank you, Jarvis, for coming in. Thank you, BurnEye. Guys, awesome show. Have a good night, guys.
Good night.
The old man built. The old man built. The old man built. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition, has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition, has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.